Welcome back to Lockdown Astronomy, coming to you from Cambridge University Astronomy. Very excited today that we get to talk about one of my favourite topics in astronomy. This is actually my field of research, which is galaxies. Lots of you would have heard of galaxies before. They are some of the biggest and the most beautiful structures in the whole universe. And today we're going to take a bit of a tour through a cosmic zoo of galaxies and look at all the weird and wonderful, interesting, different things we can see in the galactic sky. Today, as always, we're going to be doing this as an interactive astronomy conversation. So I'm going to have some quizzes for you, and you are going to have the chance to put some questions to me. So when this talk is done, we're going to have a whole section at the end designed for a question and answer session. And again, as always, we are using Slido to run this question and answer session. There are already some fantastic questions coming in, by the way. The way you can join is go to slido.com. So you go to slido.com and use the code Galaxy, which is really irritatingly hidden in the bottom left-hand corner behind some Slido bump that I don't know how to get rid of, but the code is Galaxy, Galaxy. That will get you in. Or alternatively, just scan that handy QR code that you see in the top left-hand corner. So if you go to slido.com and you can submit some questions, including the fantastic ones that are coming in at the moment. I will say that just to make sure that all the questions are nice and sensible, we're going to be moderating questions. So when you submit your question, it has to be like a kind of, we will have to tick it off on this end before it appears. We're going to do our best to let through as many questions as possible. But if your question doesn't make it through moderation, it just means we have too many to deal with. It doesn't mean your question is a bad one, but we're going to do our best to answer as many of them as we possibly can. Right, on with the science. Let's talk about galaxies. I really like starting with this picture. If you remember, those of you that have been watching this series all along, this is a picture that I showed way back in week 1 of these talks, and it shows you the Milky Way as it's seen from Earth. So a lot of the things that we've been talking about in these lectures so far, like black holes and neutron stars, they're often a bit kind of far away and you can't really see them unless you use special telescopes. Galaxies are things that you can see with your naked eye, and there's no easier galaxy to see than our Milky Way. And that is because, of course, it's the galaxy that we live inside, right? So all you have to do is go out into a clear night sky, get far away from city lights, and you can see something like this, our Milky Way galaxy, this beautiful stripe of light across the sky. What we'll do now, so we'll pan away from this real photo and go to this drawing. So this is no longer a real photo, right? This is our Milky Way galaxy seen from the outside. We can't get a photo like this, the only reason being that it would take millions and millions and millions of years for a spaceship with a camera to get to this point of view, just because galaxies are so very big. But from studying our galaxy, we understand what it looks like, and so this is our scientific knowledge put into a picture and showing you what our Milky Way galaxy looks like. But I think before we crack on and talk about Milky Way and talk about other galaxies, what I want to do is do a bit of a quiz and see what you... So I'm going to list up some of the different things that we've been talking about in this lecture series so far, and I want you to think how what of these are inside galaxies. We've got the choice of stars, gas, dust, planets, black holes, and dark matter. And I want you to have a think about what of these things do you think might be inside galaxies. So have a little think and a vote, and what I'm going to do is going to try and do some question moderation while you do that. So I'll give you a few moments to have a think and answer as best you can. I can see some fans coming in already, by the way. Okay, just give you a few more moments. So many good questions already. I'm really impressed. I think this is going to be a fantastic question and answer session at the end. I'm really looking forward to it. Lots of you thinking lots of really exciting thoughts and lots of deep thoughts about galaxies already. Okay, let's switch over and I will tell you the answer. So this, let's have a look at what people have said first of all. Stars is the most popular one. 91% of you saying galaxies have stars. That is, of course, right. But 3/4 of you saying that galaxies have dust and planets and gas and dark matter and black holes. This is my favorite kind of quiz where every single answer is right. There's no wrong answer to this. So galaxies contain all of these things. Every single one of these was a right answer. Galaxies do, of course, contain stars. They're big clouds of stars. But they also have gas. They also have dust. They have planets, of course, that are orbiting those stars. And galaxies also have dark matter and black holes inside them. So galaxies are big collections of a lot of the things that you learn about in astronomy. Fantastic, very nice. So, like, almost all of you thought that galaxies contain lots and lots of those things. So that is very, very nice to see. Okay, let's go back to the presentation because we were talking about the Milky Way. So yes, galaxies are collections of stars, of course, and planets and dark matter and dust and gas and black holes and all these different things in astronomy. So back to our Milky Way. So we are about here. So I've drawn a little "we are here" arrow towards the bottom. This shows you the location of the sun and the solar system within the Milky Way. So we're not in the middle. We are about 25,000 light years from the middle of the Milky Way. And the entire Milky Way galaxy is around 100,000 light years across, which is absolutely enormous. The words light year is a way of measuring distance in astronomy. It's a little bit confusing because you hear year, you think time, right? But a light year is a distance, and it's how far you travel if you could go at the speed of light for a year. So if you get in some spaceship and you set your engines to travel at light speed, you first of all you get to the moon in about 1 second at light speed, and then you carry on going, and then 8 minutes later you go past the sun, even though it's 100 million miles away. And then you carry on at that light speed for a whole year, and you will have travelled 1 light year. But even at that ridiculous speed, it would take 100,000 years to go across our galaxy. And in kilometres, the number is there to the right, that 950 with 15 zeros after it. The number is so big, you can see why we don't use kilometres to measure galaxies in space. 100,000 light years, it's a big number, but at least you can say it, right? So our galaxy is pretty big as galaxies go, 100,000 light years across. My favourite way of talking about how big galaxies are, I mentioned right back at the start of this lecture series. If you can imagine shrinking everything down, and imagine you've shrunk everything down so the solar system is the size of a 10p coin, or a quarter if you're in America, and you've got the sun in the middle, and the orbit of Neptune is the outer edge of that little coin. So that, that's a little coin that you could hold in your hand, right? If that's how big the solar system is, then the galaxy that I'm showing you in this picture is the size of all of North America. So some tiny coin lying in a field somewhere in America, that's the scale of our solar system compared to our galaxy. Galaxies are really, really big things. Another way of seeing how big the galaxy is, I'm drawn a little red circle here around the "we are here" sign. And what that shows you is where in our galaxy all of the stars in the night sky are located, which to me is always really incredible, right? When you go out and you look at the stars at night, it feels like you're looking at a really long way, and you really are. You're looking out to hundreds of light years sometimes, but nevertheless, even though it seems like we're looking out into kind of the infinite reaches of space, we're really only looking at our cosmic backyard. So if we were in the middle of that little red circle, all of the stars in the night sky are in that little circle. So the entire rest of the galaxy is stuff that is beyond our reach. And there are somewhere around 200,000 million stars, which, again, if you're anything like me, that's a number that's too big to imagine, right? It's many, many more stars than there are people in the world. So galaxies are really, really, really big things with lots and lots and lots of stars in them. So something you might find interesting, this is one of my favourite space facts, that around 100 years ago, astronomers thought that the Milky Way was the only galaxy there was, right? We knew we lived in the Milky Way galaxy, but we were pretty sure that that was the only thing there was. Of course, we could see other galaxies, but rather than thinking that they were other galaxies, what we thought was that they were kind of little clouds inside of our galaxy. And so astronomers would make drawings of them. This is a really famous one that an astronomer made hundreds of years ago. We now know it's a drawing of a galaxy, but what he thought at the time was that it was a little kind of whirly clouds inside of our galaxy. It seems amazing now, looking back, knowing that we live in this big giant universe. But at the time, we thought the Milky Way galaxy was all there was. There was a really famous debate in astronomy about this. It's how we learned that there is, in fact, more to the universe than just the Milky Way. It was between these two famous astronomers, one called Harlow Shapley, one called Heber Curtis. They're like the two most famous astronomers of their time. And they actually had a debate in front of an audience. An audience turned up to see these two astronomers argue. And Harlow Shapley was saying that the Milky Way is all there is. And Heber Curtis was saying this kind of exciting new idea that there are actually loads and loads of other galaxies. And at the time, it was a really big question. Is the Milky Way the whole universe, or are we just one tiny part of a much bigger universe? And fortunately for astronomers, we now know that Harlow Shapley was of course wrong. The idea that the Milky Way is all there is seems a bit silly nowadays. Now we know the universe is absolutely massive and our Milky Way is just one tiny speck. So this new idea was right. There are lots and lots of other galaxies. So if you ever go back in time 100 years, you'll be able to really surprise someone by telling them that the universe is much bigger than they think. And so now we can take like these old-fashioned drawings. So remember this drawing of a galaxy I showed you a moment ago. We can see what this actually looks like. So we take a look at this galaxy with a modern telescope and it looks like this. So this is called the Whirlpool Galaxy, and it's this kind of whirly spiral galaxy. We're going to talk about spiral galaxies in a minute. And on the right-hand side, there's this little blob, and that's like a little baby galaxy that's in the middle of crashing into it. So you can see how far we've come from little drawings on sketches of paper to really beautiful pictures from telescopes, and we can really see what galaxies look like. So now we know that the Milky Way is just one small part of a much bigger universe. What we can do is we can zoom out from our Milky Way and have a look what's around it. And so we're going to do that here. So this is a program called Universe Sandbox, which I think you can download for your own computers if you want to have a look around the universe. So I'm going to scroll out from the Milky Way, and then we're going to pan our camera around. And what we can do is we can really get a sense of our Milky Way hanging there in space and look around nearby. And if we swing the camera around right, we can come to this galaxy here. So this is the Andromeda Galaxy. If I zoom out, you can get a sense of how big the distance is between them, right? The Milky Way galaxy is in the middle, and that's the Andromeda Galaxy around the top. I'll swing the camera around. This is what galaxies look like when they're separated in space, right? This is what it would actually look like if you're away from the Milky Way and the Andromeda Galaxy. The Andromeda Galaxy is quite interesting and useful because it's our way to see a nice big spiral galaxy. You can think of it as the twin galaxy to our Milky Way, right? The Milky Way and Andromeda are pretty similar, but it can be, in lots of ways, it's quite hard to study the Milky Way because we're inside it. But the Andromeda Galaxy, it's out there in the sky and we can look at it from the outside. And so this is a nice video I'm going to show you now, zooming into the Andromeda Galaxy so you can see what a spiral galaxy looks like from really up close. One thing I really like about this video is that it shows you how many stars are inside a galaxy. I gave you this number before, something like 200,000 million stars inside the Milky Way, which is just such a ridiculous number, you can't even imagine it. But when you see a galaxy that's full of stars, you can get a sense of what that really means to have that ridiculously large number of stars. And so this is the Andromeda Galaxy now. We're going to zoom in and zoom in and zoom in. And suddenly it starts looking like a beach or something, and you can see these little speckles that look like sand or sugar, and each one of these little speckly dots are a star. So not just the big ones, right? All of these little speckly dots all over the screen, tens of thousands of them in this picture that I'm showing you right now. These are all stars, and this is just one small part of that much bigger galaxy. So that's how many stars are in a galaxy. It's a really big number. So let's look at some different types of galaxies. So the Milky Way galaxy and the Andromeda Galaxy are both spiral galaxies. They look pretty similar. And the spiral galaxies are one of the main types of galaxy. When people think of galaxies, you often think of a spiral galaxy. They're some of the, for me, they're some of the prettiest, most like impressive looking kind of galaxies. It's the kind of galaxy you want to print out as a poster and put it on your wall, right? They look like these lovely kind of whirlpool-y spirals. So this is a nice one. This is a really nice one. This is one of my favorite galaxies called M81. You can see all the different pretty colors. We're going to talk about this galaxy in a little bit and show you what all the different colors are actually telling us. And this is another really, really nice one. These are all real photos, by the way. All these galaxies I'm showing you are real pictures from telescopes of galaxies out there in our universe. So spiral galaxies, these like really, really pretty, beautiful whirlpools of hundreds of thousands of millions of stars, all being held together by gravity. There are also galaxies called elliptical galaxies. And these don't look quite as pretty as spiral galaxies. This is a famous one called M87. And it's a slightly boring looking blobby egg-shaped thing, if you ask me. They don't look quite as cool as spiral galaxies, but the really cool thing about elliptical galaxies is how big they can be. Elliptical galaxies can be absolutely gigantic. The biggest galaxies in the universe are all elliptical galaxies. I'm going to show you on this picture now how big our Milky Way galaxy is compared to M87. Right there, down underneath it. Remember I was saying before that our Milky Way is a pretty big galaxy, right? Something like 100,000 light years across, but our Milky Way galaxy looks tiny compared to M87. These elliptical galaxies can be absolutely massive, some of the biggest galaxies out there in the universe. And this is one of the biggest galaxies in our universe, IC 1101. Again, it's a slightly rubbish name for a really, really cool galaxy. This galaxy is around 6 million light years across, which is big enough to swallow the Milky Way and Andromeda and all of the space in between. Remember that universe sandbox kind of computer game view I showed you before of the Milky Way and Andromeda? IC 1101 would swallow both of those together. This is a bit of a cartoon drawing of how big that galaxy is compared to the Milky Way and Andromeda on the left-hand side. And even M87, which was a pretty big galaxy in itself, is dwarfed by this absolute monster of a galaxy, IC 1101. So elliptical galaxies are really, really cool because of how gigantic they can be. There are also one of my favourite types of galaxies called peculiar galaxies. And these are all the weird galaxies that don't really fit any normal type. And they're often there because they are doing interesting things like crashing into each other. So this is a famous one called the antenna galaxies. Again, this is a real picture of two galaxies that are in the middle of crashing together. So you can see one core of one galaxy that's down the bottom and one that's more towards the top right. And these two galaxies are kind of whirling together in this millions of years long collision. This is a really interesting galaxy for us in the Milky Way, because some of you might know that the Milky Way and the Andromeda Galaxy are on a collision course. So the Andromeda Galaxy and the Milky Way are heading towards each other, and in around 5 billion years' time, that's about 5,000 million years, the Milky Way Galaxy and the Andromeda Galaxy are going to collide and crash together. And when they do, this is what they're going to look like. So this is like a glimpse into our own future. This is what the Milky Way and the Andromeda Galaxy are going to look like mid-collision, way, way, way in the distant future. It makes me wish I could be around to see it. I would love to live 5 billion years in the future to be able to see what that cosmic collision is going to look like. This is a super cool one. This is called the Porpoise Galaxy, and you can kind of see why. So it's a spiral galaxy that's being torn apart by the massive gravity of that elliptical galaxy down there. So again, remember, this kind of like this shimmery blue curtain of light is again a spiral galaxy, hundreds of thousands of millions of stars and all that stuff that we were talking about before, and it's being kind of torn apart into this diving dolphin shape by the gravity of an even bigger galaxy down below. This one's really amazing. No good name for this one. It's just called UGC 1810. Astronomers often have to give things names that are a bit less interesting, just because there are so many galaxies out there. We can't give them all exciting names. But it's a boring name for a really, really cool galaxy. So it's a spiral galaxy that's been disturbed somehow, like something has kind of crashed into it. And so the spiral arms are kind of slightly unwinding. And so you can see it kind of unraveling in space like this. This is a really nice galaxy. So a lot of these peculiar galaxies are caused by galaxies crashing together. Like, remember the antenna galaxies I said, where the Milky Way and the Andromeda are going to crash together and look something like the antenna galaxies. A lot of these weird galaxies, a lot of the strangest and the prettiest galaxies we see in the sky are the result of galaxies colliding. One of the ways we can actually know that is that we can build galaxies inside a computer. One of the things that astronomers do is take very powerful computers called supercomputers and build toy galaxies inside them, a bit like a very powerful computer game. And then we can take these computer game galaxies and crash them together and see what it looks like. And when we do it properly, the galaxies that we crash together inside of our computer game look just like galaxies out there in the real universe. So I'm going to show you this amazing video now of showing you some of these simulated computer galaxies and then comparing them to galaxies out in the real universe. And you can see that they look really similar. So we're going to start off with two galaxies in our computer universe. And then we're going to pause and go backwards and forwards between the real worlds. So that's two real galaxies that are just about to collide. And then we can press play again on our computer game and smash these two galaxies together. And then if we press pause, we can then switch again to the real universe and see there are two galaxies that look just like this, that are in this stage of colliding. And then we can press play on the computer simulation again, and you can see the galaxies kind of smash together and get whirled around by gravity. And again, there are two galaxies in the real universe that look just like this. Let's press play again, go back, and then you can see gravity is pulling these two galaxies together again for another smash. And again, there are two galaxies that look just like this, these long tails of stars that have been pulled out by the collision. I really like that galaxy, that one's really pretty. And then again and again and again, as you go forward, you can just smush galaxies together. And at every point, you see galaxies in the real world, out there in the real universe, that look like this. And so this explains all of these weird and wonderful galaxies, these peculiar galaxies that we see. They're galaxies smashing together in different ways. I should say, of course, that this video is really, really, really sped up. Galaxies being so big take a long time to do anything, so galaxies crashing together would take tens of millions of years, hundreds of millions of years to kind of finish the collision. So what I want to do now is take a bit of a closer look at a single galaxy. We've been looking at lots of different galaxy types. What I want to do is take a closer look at a single galaxy and give you a bit of an astronomer's eye view and show you what an astronomer would see when they look at a galaxy and see all the different bits in the picture and what it's actually telling us. I'm choosing a galaxy that is quite easy to see in the night sky if you've got some binoculars. So I'm showing you here where it is in the night sky. So this galaxy is called M81, and you can find it near the constellation of Ursa Major. So Ursa Major, the Big Bear, is the scientific name for this constellation that I always think looks a bit like a saucepan. It often gets called the Plough or the Big Dipper. It's one of the most recognizable constellations in the night sky. And if you have the pan of the saucepan on the right hand side and you kind of go up and right a little bit, there is the galaxy there. And if you've got a pair of binoculars, you could take a look at it. So that could be a challenge for tonight. It looks like the weather, at least here in Cambridge, is quite nice at the moment. So maybe you can go and try and spot this galaxy tonight once it gets dark. So what we're going to do is zoom in now. So if you remember, this is the galaxy I showed you before, M81. What I want to do is show you some different things in this picture and show you the different things that astronomers would see in this picture. So first of all, remember that a galaxy is a big cloud of stars. So all this kind of misty, foggy stuff that you can see in this galaxy, it's just stars, right? You can see a lot of very, very bright stars in the bottom right and the top left-hand corner. There's kind of the spiky stars. Those are ones that are very nearby in our own galaxy. So the galaxy that we're looking at, this kind of swirly thing in the background, is much, much, much further away than those spiky stars we can see on the edges of the picture. And the galaxy that we can see is just a big cloud, of course, as all galaxies are, of millions and millions and millions of stars. And all this foggy stuff is these stars that are too many to see individually. The reason it looks like this, and the reason galaxies often have different shapes as well, is because we see them from different angles. So galaxies are flat, right, like pizzas or frisbees. And the same galaxy would look differently depending on how we see it. So if we see a galaxy face on, it's going to look like that. If we look at the same galaxy edge on, it might look something like that, right? Imagine looking at a pizza kind of from above, face on, rather than looking at pizza sideways, so it's kind of really, really thin. You're just looking at the crust. That's what a galaxy looks like. And so depending on the angle, we can look kind of different. This galaxy here, M81, we're pretty much seeing it face on, but it's got a bit of a tilt. If you look at the picture, you can almost see it as a 3D thing. You can imagine it as a disc, a kind of frisbee shaped thing that's been slightly tilted away from us. So it's a pretty big galaxy, just like the Milky Way, somewhere around 90,000 light years from side to side, and which is that very, very large number of kilometers. And of course, it's a spiral galaxy. The way astronomers define a spiral galaxy, you can see these spiral arms. I'll mark them out for you, right, so you can actually see them. So there's one spiral arm, starts from the middle, then curls round to the edge, and the other spiral arm starts from the middle and curls round the other way. Right, so these are the spiral arms of the galaxy, and that's what makes a spiral galaxy rather than any other type of galaxy. These lovely, pretty whirlpool spiral arms that it has around it. And of course it's spinning, as all galaxies are spinning round. This galaxy is spinning round, and it will take hundreds of millions of years to complete one rotation. If you look at it, you can actually see that it looks like it's spinning, right? It looks like a whirlpool that's spinning round in space, and that's exactly what's happening, but it's just so big it takes hundreds of millions of years to spin round once. The other thing that you'll notice, and this is why people, including me, like to hang pictures of galaxies on their walls, is that they come in loads of really, really pretty colours, right? When you see a picture of a galaxy, the colours are always really strikingly beautiful. But the really amazing thing is, as well as being really pretty colours, they are telling you things about what's inside the galaxy. And so what I want to do with this picture is just break down the different colours and tell you what you're actually seeing in this galaxy, kind of decode the picture a bit. So first of all, so this is the original picture with all the colours together. First of all, I want to pull out the red bits, and let's just get rid of those other colours and isolate the red bits. What those little red blobs are baby stars forming. They're stellar nurseries, and you can see there's lots of these little red dots and little red blobs all the way in that loop around the galaxy. They're little stellar nurseries. So each red dot that you can see is a little cocoon of baby stars being formed, surrounded by dust, and all those baby stars are heating up and heating all the gas and dust around them, and they're kind of glowing nice and hot, which is why they come up red in this picture. So all those little red dots you can see is a little stellar nursery of new stars being born. And then if we go back to the original galaxy, the original picture of the galaxy with all the colours, you can still see those red dots, right? So those red dots that I just picked out, those are the stellar nurseries. Those are the new stars being born. What other colours can we see? We can see blue, right? Blue's a really, really distinctive colour that stands out. So if we get rid of all the other colours and just highlight the blue, what we're seeing here, what the blue light is showing you in galaxies is young, hot stars. So not baby stars anymore, but the youngest and the hottest stars in the galaxy. And they are all blue. And you can see they live in the spiral arms, right? So we get rid of the other colours and just leave us with the blue. We can still see that the galaxy is a spiral. We can still see this whooshy kind of whirlpool thing. And that's because the spiral arms in the galaxy is where all the young, hot stars live, in blue. And then if we go back to the original picture of the galaxy again, we can still see the blue, right? So the blue in the galaxy is telling you the young, hot stars. So what's left over? We've done the red dots, which is where the baby stars are. We've done the blue, which is where the young hot stars are. And what's left over is that kind of orangey stuff in the middle. So let's do the same thing. Let's get rid of all the other colours and just look at the orange in the middle of the galaxy. So this is called the bulge of the galaxy. In the middle of a spiral galaxy is lots of old stars. So we're still just seeing stars here, right? All this kind of like orange cloudy stuff in the middle. It's still just stars. But the reason it's kind of orangey is because it's loads of old stars. They're a bit old and tired and colder compared to the blue, young, hot stars on the outside. It's lots of older, colder stars in the middle of a galaxy, and that's why it's kind of orangey. And again, if we go back to the original picture of a galaxy, we can see all the colours again. So you can see those old stars in the middle, you can see the young hot stars around the edge, and you can see the little blobs of baby stars being formed. And then so we can play the same game with lots of different galaxies now. So this is like the key to decoding all galaxy pictures. So if we look at this, let's look at this M51, this whirlpool galaxy I showed you before. You can see exactly the same things in this picture, right? You can see the red of the baby stars being formed. Every little red dot you can see is a little stellar nursery. Lots of baby stars being cocooned up in their dust and growing nice and hot and lighting up all the gas around them. And that's what they're showing you. The blue that you can see in the spiral arms, just again, is young stars. It's young, hot stars that are kind of swirling around the galaxy. And the same is true of the red. If we look at the old stars, we can see the old stars in the middle, the bulge in the center of the galaxy. And also, for this one's interesting, you can see that galaxy on the right-hand side, that little baby galaxy that's crashing into the big galaxy on the left. That's bright orange. That has loads of old stars in it as well. If we go back to the original, you can see how it all comes together. You can see the combination of the old stars in the middle, the blue stars in the spiral, and those little red dots of the baby stars being born. The antenna galaxies as well. If you go back to this one, you can see the same thing, right? You can see the old stars, the young stars, the baby stars being born. This one's really cool because there's loads of red in this picture, right? So there's absolutely loads of baby stars being born in here. And that's because when galaxies crash together, it's one of the main ways that new stars get formed. So one question I want to ask, I want to try and answer before the end, or at least give you an idea of what the answer might be towards the end, is how many galaxies are there? And first of all, I'll say we don't actually officially know the answer to this. We haven't counted our way through the entire universe to see how many galaxies there are. What I want to do is give you like an idea of the best experiment astronomers have done to try and guess or try and get an estimate of how many galaxies there are. So what we did, we took an amazing photo of this teeny tiny patch of sky that's much, much smaller than the full moon. So think about how much of the sky the moon covers. Then think of an area the size of that red circle, like much, much, much smaller than the moon. A nice way of thinking about it is it's about a quarter the size of your pinky fingernail if you hold it at arm's length against the sky, right? So you can do it now. Hold your pinky fingernail up kind of against the roof and imagine how much sky would be covered by a quarter of your pinky fingernail. And what we did, we took that tiny, tiny, tiny patch of sky and took this amazing photo. We took a really powerful telescope and gathered all the light in that tiny patch of sky and took this photo. So I think this is one of the most important photos ever taken. It's a photo of all of the galaxies in that teeny, teeny patch of sky. The amazing thing about this photo is that every single thing in it is a galaxy. There's about 10,000 galaxies in this picture, in this tiny patch of sky. And remember, we've been talking about how big a galaxy is, right? Just one galaxy is hundreds of thousands of light years across, and hundreds of thousands of light years across, and hundreds of thousands of millions of stars inside it. And that's just one galaxy, and there's 10,000 galaxies in this picture, and this is just one very, very tiny patch of sky. So we now know that there are more galaxies in the entire universe than there are even stars in a galaxy, right? There are hundreds of thousands of millions of galaxies in the universe, which means there are more stars in the universe than there are grains of sand on every beach in the world. And they are all part of these kind of big, beautiful galaxies. So this is why I love galaxies so much. Like I said at the start, my galaxies are my area of research. What I like to do is try to understand how galaxies are born, how they grow up, and where they come from. And I think it's an amazing thing to study because galaxies are some of the biggest and the prettiest things in the entire universe. So I think that's quite a good... We've been going for about half an hour. I think that's quite a good time to stop and go and answer some questions. I'm going to just take a couple of seconds now to moderate and to let through some of these questions because there's lots of fantastic questions coming through. We're doing our best to come through. So just give me a couple of moments and then we will go over to the questions. Okay. Top question. So for some fantastic questions coming in, by the way. What is the biggest galaxy that we know of, and how big is it in comparison to the Milky Way? Asks an anonymous person. So I think this was answered during the talk. So the biggest galaxy that we know of is this galaxy called IC 1101, which is about 6 million light years across. It would dwarf the Milky Way. It's big enough to swallow the Milky Way and Andromeda and all of the space in between. So very good question, anonymous. Trying to tick you off. Maya S, age 6, says, what is the strangest shaped galaxy? That is a really good question. There are lots of very, very strange galaxies. These are called, lots of the peculiar galaxies are the very strange ones. One of the strangest there's something called the Ring Galaxy. You could look it up on the internet. The Ring Galaxy. I should have had a picture in here. It's a ring of new stars that have been formed because two galaxies have crashed together. So it's two galaxies in the middle of colliding, and one galaxy has exploded and caused this lovely kind of ring shape of new stars. I think that's one of the strangest shaped galaxies. It's also one of the prettiest. Anonymous asks, when will the Milky Way and Andromeda collide? So it's going to be in about 5,000 million years, or 5 billion years, which is a very long time in the future. The interesting thing is that it sounds quite dangerous, right? When we think of the Milky Way and the Andromeda Galaxy colliding, it sounds a bit like it's going to be kind of catastrophic for anyone living inside these galaxies. It's actually going to be fine. Because stars in galaxies are so far away from each other, the chance of any two stars actually crashing together when galaxies collide is almost zero. So the solar system is safe, right? There's no way the solar system is going to have any problems when the Milky Way and the Andromeda Galaxy collide. The main thing that's going to happen is that this night sky is going to get really pretty. Remember that remember that antenna galaxy picture I showed you before, and it had all those red dots which were showing you the baby stars being formed. Galaxies crashing together is one of the main ways that baby stars get formed in the universe. So what's going to happen when the Milky Way and the Andromeda Galaxy collide is there's going to be a fireworks show of baby stars, and the night sky is going to get really, really pretty. So that's why I kind of wish I was around to see it. I think it's going to be really, really spectacular. Tristan, age 7, asks, what is the smallest galaxy? So these are types of galaxies called dwarf galaxies, and even a dwarf galaxy is pretty big by any kind of human standards. So dwarf galaxies still have millions and millions of stars in them. There are lots of dwarf galaxies orbiting our Milky Way. And I'm not exactly sure what the name of the smallest one is, because there are lots and lots and lots of them. But the smallest type of galaxy is a dwarf galaxy that has a few million stars, and that's much, much, much smaller than our big Milky Way. Anonymous asked, long, long ago in a galaxy far, far away, what would they have meant in the late 70s compared to what we know now? I guess you mean, so yeah, what have we learned about galaxies since the late 70s? We've learned an awful lot about galaxies since the late 70s. One of the biggest things we've been doing since the late 70s is understanding how galaxies are born, and how galaxies grow, and how galaxies turn into the galaxies we see nowadays. Because when we look back to the early universe, what we see are baby galaxies, like the very first galaxies to form, and they don't look anything like the galaxies that we know in the everyday universe. We don't see these kind of big, pretty spirals. They all look kind of chaotic and messy in the early universe. And so a lot of the work that we've been doing since the late 70s is to look at how galaxies kind of grow up over the billions and billions of years and turn into the galaxies that we know nowadays. Another thing is understanding the role of black holes in galaxies. So every galaxy has a very big black hole in the center, and we know a lot about how the black hole kind of affects the galaxy around it. So we've learned an awful lot. I think an astronomer from the 70s would be very, really happy if they came and could have a conversation with us nowadays. They would learn a lot about galaxies. Tristan, age 7, another fantastic question, Tristan. What characteristics define a galaxy? So a galaxy is just generally a big cloud of stars, first of all, and gas and dust and dark matter. That's what a galaxy is. So as we've seen, I've shown you lots of different pictures. They come in all different colors and shapes and sizes, but a galaxy basically is a big cloud of stars and gas, and other stuff as well. Jake, age 5, great question, Jake. Why are galaxies called galaxies? So this goes back to some people thousands of years ago called the ancient Greeks, which you might have heard of if you've done a bit of history in school. So before we knew about any other galaxy, we could still see the Milky Way. Remember that picture I showed you right at the beginning, showed you that nice starry sky with the strip of light across the sky. That was the Milky Way. And so people thousands of years ago, they didn't know what the Milky Way was, right? They didn't know much about astronomy. They didn't have telescopes. The Milky Way was a mystery, but they saw this really pretty silvery light across the sky. And what they called it the Milky Way because they had this myth about a goddess who accidentally spilled milk across the sky, which caused this silvery band. And galaxy is kind of it's Latin for Milky Way. So it comes from the word galaxy comes from Milky Way in the language of people that spoke it thousands of years ago, and that's because they thought it looked a bit like milk in the sky. So it's a really old word that comes from people that thinking that the Milky Way looked a bit like milk before we understood what a galaxy actually was. Aprigit asks a fantastic question. How do we estimate what the Milky Way looks like? That's a really good point because we're inside the Milky Way, it's very hard to study, right? We can look at the Andromeda Galaxy in a telescope and see what a spiral galaxy looks like from the outside. The Milky Way is harder to study because we're inside it. And it's especially hard to study because it's full of dust. And dust, it's full of this stuff that blocks our vision and stops us from seeing it properly. So understanding what the Milky Way really looks like had to wait until we invented radio telescopes. And so radio telescopes, they a bit like radio dishes, like radio waves that we use to kind of send signals around Earth. We can use radio dishes to listen out into space and collect different types of lights, different types of signals from around the galaxy that don't get blocked very easily. And so when we invented this new type of telescope in the 1950s, that let us kind of map our galaxy by seeing through all of the stuff that would block our vision normally. So up until like the 1940s, 1950s, we didn't really know what our Milky Way looked like. We had to wait until radio telescopes came along to let us make a proper map of it. Sid asks, do galaxies die? That's a great question. The answer is yes, they absolutely do die. First of all, we have to say what die really means for a galaxy, right? It means because, a galaxy can't just kind of fall over and stop living, right? It's a cloud of stars. What we mean by a galaxy dying is that it stops making new stars. Right, so galaxies make new stars all the time, right? The Milky Way is making new stars right now. Like every year, the Milky Way makes a couple of new stars. All of the galaxies I've shown you so far in this talk, pretty much all those pictures, galaxies are making new stars. And that's part of the natural life cycle of galaxies. Like in a galaxy, the stars are born, and the stars live their lives, and then the stars die. Then that just goes on and on and on. But if a galaxy stops making new stars, that just gets cut off, and all the stars in the galaxy just get older and older and older, and then go out. So what we say by a galaxy dying is that it stops making new stars, and that absolutely does happen. So sometimes when the black hole in the middle of a galaxy, for example, wakes up, it can kind of violently blow away all the stuff inside the galaxy and prevent the galaxy from making new stars. So yes, galaxies die all the time, and sometimes they are killed by their black holes. Fantastic question, Sid. Rory, age 4, asks, how do stars gather to make the Milky Way? That's a really, really good question. So the answer really is gravity. So gravity is the force that pulls things together, right? If you lift something up off the floor, ideally something not valuable, and then you drop it down onto the floor, it will be attracted. It's pulled down to the ground because of gravity. Gravity pulls things together. And the same is true of our solar system. So the reason the Earth is going around the sun is because the gravity of the sun holds it there and holds our solar system together. And the same is true for the whole Milky Way. It's just like the solar system, but much, much, much bigger. All of the stars are held together by gravity. Gravity is amazing. It's the force in the universe that holds all the stuff together. So the stars in the Milky Way are all held together by the gravity of the galaxy. Fantastic question, Rory. A random space nerd says, how is a supermassive black hole formed? I have to say that this is still something of a mystery. So for those of you that have been following this series, we will know there are a couple of different types of black holes. There was a talk on black holes a few weeks ago, which you can find on my YouTube channel. And little ones the size of stars are formed when stars die, but every galaxy has a supermassive black hole in the center, and how they are formed is still something of a mystery. We know that a supermassive black hole is formed at the same time as a galaxy, and the black hole in the middle and the galaxy have to kind of grow up together, because like the properties of the black hole are really closely connected to the properties of the galaxy. So we know they're almost like siblings that kind of grow up together. But how they're actually formed originally, we don't totally know. It might be to do with the stars in the universe. Maybe if the very first stars in the universe were much, much bigger than when they exploded and formed black holes, they would have formed a much, much bigger black hole. But right now, it's a bit of a mystery. It's one of the things that astronomers are actually working on to try and understand how supermassive black holes formed. Maybe some people listening to this now need to study in school and become astronomers and help us solve these unknown questions. Kenneth, age 7, says, where is the best place to see the Milky Way from? So the only rule is that you have to get away from streetlights. You have to get to a really, really nice dark sky. So if you are under a streetlight, you won't be able to see it at all. So the best place is away from a city, out in the countryside. You don't have to go anywhere particularly special. So where I live in a little village near Cambridge, and it's slightly away from the streetlights in the city, and I can see the Milky Way from outside. So the best way to see the Milky Way is just to drive, or get someone to drive you away from a city to somewhere where the night sky is really dark, out in the countryside. Like if you go camping, like if you join the Scouts or something and go camping, sometimes that's a really good place to see the Milky Way. You just need a night sky that's really, really nice and dark. It's quarter to. I'll do a few more questions and then it will be time to finish, I think. Gonna tick off Kenneth's question. That was very, very good. Okay, a couple more questions. Tristan, age 7, how do galaxies form? This is a really, really good question. It would take a very, very long time to give you a proper answer because the answer is quite complicated. The very, very short answer is that they need dark matter. So imagine going back in time to the early universe. Let's travel billions of years back in time to the early universe when galaxies haven't formed yet. The first thing in the universe to form are clouds of dark matter. So dark matter feels gravity, and so you get kind of big clouds of dark matter forming first. Then all of the gravity of that dark matter starts attracting gas and stars, and that forms a galaxy around it. So if you like, dark matter provides like the scaffolding or the skeleton that galaxies form around. And basically you just get a whole lots and lots of gas kind of gets attracted to this dark matter and then forms millions and millions of stars, and then eventually you have a galaxy. Like I said, giving it's a really, really big complicated question, so giving you a proper answer would take a very, very long time. But the short answer is you start off with a cloud of dark matter, then the gravity of that dark matter pulls in lots of gas and stars, and then new stars get made, and then you end up with a galaxy. Another one from Tristan. Do galaxies come in standard shapes? I think this is one of the questions that was asked before the talk. Hopefully the talk has answered the question. The answer is absolutely no, right? There are some like similar things, that you get some spiral shapes and some elliptical shapes, but all galaxies are kind of weird and wonderful and different. So there's absolutely no standard shape for a galaxy at all. I think I'll just answer these two questions on the screen and then we'll be done. So Laura, Amber and Ruby ask a really good question. Can galaxies sink in deep space? The answer is no, and the answer is no for a very interesting reason. So when we think about what sinking actually means, right? So you think about like a ship sinking in the ocean. Why does a ship sink in the ocean? It sinks because it's pulled down by the gravity of the Earth, ultimately, right? It's because the water gets in and it's no longer has enough air in it to float, and so gravity just manages to pull it downwards. So what sinking means is being pulled down towards something's gravity. But out in deep space, there's nothing like much bigger than a galaxy to kind of pull them downwards. So in general, galaxies just kind of float out there in space on their own. There's not like a kind of a big thing to pull them downwards because there is no down in space. I hope that makes sense. I've lost questions. I've lost track of the questions that we were going to be answering. We've done Tristan's question about standard shapes. I've answered how many galaxies do we know about at the very end of that last talk. Hundreds of thousands of millions in total. And that is the answer to Apogit's question as well. And Oliver's question as well. Lots of the same question coming through. Yeah, hundreds of thousands of millions in total. Here we are, Abby and Jack's question, I think, because I think I've answered the other two questions now. Abby and Jack, and this will be the last question I'll do. Which galaxies can we see in the sky with the naked eye? So with the naked eye, really, we can only see the Milky Way, but you only, because galaxies they tend to be quite spread out and quite hard to see with the naked eye. But if you get a pair of even small binoculars, you can see the Andromeda Galaxy, and you can often see M81, which is the galaxy that I showed you all those different colors in. So just with the naked eye, it's really only the Milky Way. But if you get some even small binoculars, you should be able to see lots of other galaxies. Andromeda would be the first one that I would go and try and look at, because that looks really amazing. Okay, I think we've been going for 50 minutes. So that's a good time to finish. Thank you so much for listening. I hope you've enjoyed this conversation about galaxies. If you've enjoyed this and you want to hear more of this type of thing, you could please consider subscribing to our YouTube channel below. We also are doing these talks every week. This time next week, we're going to be talking about a very cool subject, crashing black holes together, and what that means for gravity and how crashing black holes together can shake the universe itself. So that is going to be on this time next week. Thank you very much for listening.